In this lesson, we want to review functions. Functions are the basic mathematical objects that we're going to be working with in calculus. The first thing we should do is we should probably look at the definition of a function. A function is a rule that assigns to each element x in a set D exactly one element, and we call this element f of x in a set E. Now, this x is what we call an input value. And this f of x, this is an output value. Now, if we took the collection of all allowable input values, that set D is what we refer to as the domain. And if we took the set of all output values, the set of all output values, that's going to be what we call the range. So the range is a collection of values that lives inside the set E. Let's look at an example next. Frequently, we will write things like y is equal to f of x. And all this is saying is that the y values are going to be our output values and the x values are going to be our input values. So remember, our domain is labeled with D. So let's put a D here in our first set, and we're going to label all of the input values. So we got -2 as an input value, we have -1 as an input value, we have 0, we have 1, and we have 2. Our output values are going to live inside a set E. So let's put an E for that second little oval there. And we're going to label the output values, but we're not going to duplicate them. We're just going to write each y value once. We're going to have 0, we're going to have 1, and we're going to have 4. And to indicate the rule, we use arrows. So -2 maps to 4. So the rule says put an arrow going from -2 to 4. -1 maps to 1, so we're going to arrow going from -1 to 1. 0 maps to 0, so we're going to put an arrow going from 0 to 0. 1 is also going to map to 1, so we're going to put an arrow going from 1 to 1 like this. And 2 is going to map to 4, so we're going to put an arrow going from 2 to 4. So remember, our definition of a function has two components. The first component is that it's a rule that's represented by the arrows, but the second component says that every input has exactly one output. So we can see that -2 only has one arrow coming out of it. -1 only has one arrow coming out of it. Same with 0, same with 1, and same with 2. So both conditions of that definition of a function are satisfied. Let's take a look at another example. This time we'll look at an example of a function or a relation that is not a function. So a relation is just a XY pair. And again, we have the same situation as before. So our domain is going to be called D. And we're not going to write duplicate elements. So we're going to put a 0, a 1, and a 4 for our input values. Our output values are going to be contained in that set E. And we're going to label our output values of -2, -1, 0, 1, and 2. And the rule associates the x value with the corresponding y value. So we can see that 4 is going to go to -2, so we put an arrow going there. We see that 1 is going to go to -1, so we're going to put an arrow going from 1 to -1. 0 is going to go to 0. So far, everything is okay. But when we look at the next ordered pair, it says that 1 also goes to 1. So we're going to put an arrow going like this. And it says that 4 is going to go to 2. So we put an arrow going like this. So the rule part is still satisfied. In other words, every input has an output value, but the exactly one condition is violated. We can see that while 0 goes to 0, So there's only one arrow coming out of 0, so that's okay. But 1 is actually going to two different values. 1 goes to -1, 1 also goes to 1. Same thing with 4. 4 is going to -2, 4 is also going to 2. So in this particular situation, we see that this is not a function. And the reason why is that 1 has 2 outputs. 4 also has 2 outputs for every 1 input. So that violates the exactly 1 criteria that we had. Another way that we can work with functions is, instead of looking at a table of values or an arrow diagram, we can actually look at graphs. So when we look at this graphical point of view, a graph in the xy plane is the graph of a function of x if and only if no vertical line intersects the curve more than once. So let's take a look at an example. Let's look at example 3. If we look at example 3, we see that this vertical line intersects the graph only once. If I draw another vertical line, we can see no matter what vertical line I draw, all these vertical lines only intersect the graph at most once. And it's okay if it doesn't intersect the graph at all. Let's look at another example. In example 4, we'll look at the graph of a curve, and we'll see that this curve does not correspond to a function. So let me draw a vertical line, but I'll draw it to the left of 0 over here. I'll draw it like this. And we can see that this vertical line doesn't intersect the curve at all. So in this case, there's no issue. If I draw a vertical line at x equal to 0, we can say that in this particular case, it only intersects the curve exactly once at 0. So we're still fine. It doesn't violate the vertical line test. But let me draw now a third line. I'll draw a third line at the value of 9. When I look at this vertical line here, we have an issue. We see that it is going to, at 9, it has two y values. It has a y value of 3, and it also has a y value of -3. So in this third line situation, we definitely have an issue. The graph does not correspond to a function. And what we see is we see that the input value of 9 actually goes to two different output values. It goes to an output value of 3 and an output value of -3. So the input 9 has two output values. In other words, it fails the vertical line test. So I hope this review helped you understand, the definition of a function. Okay, folks, that's it for this video. I hope you enjoyed it. Let's talk again soon.